Good morning, ladies and gentlemen of calculus, and Gavin, dare I say.
Dare you say?
My main man, Gavin.
My main man. We're busting you out, Gavin. Don't go away then.
All right, so what we're doing is we're taking what we did in note card 47, which was like a definite integral, and now we're having another instance of this, which is area between curves. And so what you have is you have two types of situations for these. I'm going to kind of explain graphically what they are. Sometimes what you'll see for area between curves is you'll have one function up here which is f of x, and then you'll have another function down here which is g of x. And area between curves might be if you have like limits of bounds of integration like this. You're trying to find this area right like this. Okay? And so basically what you're doing is you're taking your limit from a to b of f of x minus g of x, and that's what that is. All right. Now there's another version of this problem that we're going to find what they are. Is often you're going to be given problems like this where I'm going to go ahead and reconstruct. You'll be given problems like this where you'll have an f of x like this, and you'll have a function g of x like this. And so this one's going to be f of x, and this one's going to be g of x. In this instance, what you're going to have to do is you're going to be given, or you're going to find these intersection points between the curves. So the question will say, find the area between these functions. And so you have to go and use your algebraic reasoning to find what these x values are. And then once you have that, you can set up the integral to find this area. So we're really getting into applications, so it's kind of an extension of what we've been doing. And so what you're going to be able to do is you're going to be able to, sometimes you can take these areas separately and subtract them, or sometimes you can combine like terms and combine these two things in a single function and work with it that way. So and you can, if you can do this, sometimes there are calculator problems where you'll need to have a calculator to do some of these. Sometimes you want to have a calculator because this thing's going to be really tedious, and so the calculator can make your life easier if you set up right. But even if it's a non-calculator problem, you can use your calculator to check to see if you have. So that's one thing you have available to you then. But everything else is the same thing. So let's go to this problem here. So here we have this situation right here. Find the area of the region in the first quadrant that is enclosed by the graphs of y equals x squared plus 8 and y equals x plus 8. So I want you to follow along with what I'm doing here. So what I like to do first of all in these things is I like to sketch a graph of this to get an idea of what is happening. And so now if we sketch a graph here, so I draw and we're talking about quadrant 1, so we really only need quadrant 1 to deal with. And then we graph these two functions. What do these graphs look like? Well, we have x cubed plus 8. So what I'm going to do is I'm going to use what I have available to me that you don't have. Maybe you'll be jealous of me. And you go up here and you can just move this up by 8, and now you have x cubed plus 8, right? Does that make sense?
Yeah.
And now you have this one, y equals x plus 8. So and that one is going to look like what? That one's going to look like something like this, right? And now you're going to have your, how do you determine what your limits of integration are here? I'm clawing back a little room here with my erasure. How do you find what your limits of integration are here?
What's enclosed? It says in the first column.
What-
The intersection.
So what are your intersection points here in quadrant 1?
Zero.
So we have x equals 0, and that you should be able to see that pretty easily. What else is x equal to here? If you don't know what it is, you can just go like this.
1.
Yeah, so Aaron thinks it's 1, so we can go like this, right? And then so what we get is x cubed equals x, or we can write it as x cubed minus x is equal to 0, and then we have x times x squared minus 1 equals 0. So what do we have here? We have x equals 0, x equals plus or minus 1, right? So, because we have x equals 0, and we have with this x equals plus or minus 1. So what is this going to be here? 1. So what is going to be our, so here you can set this as f of x, g of x. So the one on top we can call f of x. The one that's lower we can call g of x. And now you can work out your integration. So I want you to work out your integration on this. And we'll go over this in a few minutes, okay? Going back to the guide here, at the title of the note card here, see that? Do that. Go over this in a couple minutes.
Mr. Jim, when are we spending the bathroom?
Pardon me?
When we're done with this, we're in the bathroom.
Yeah, it'll be fine.
Miss Glory, will you go to the girls' back bathroom, please? Thank you.
Maybe not.
That was a timely announcement. Or untimely, however you want to say it.
Not too long. Just trying to figure out what you're
Show you.
So, real quick, for the B and A, so the values for that, so that's the values are 0 and then 1 plus the
Yeah,
maximum.
yeah. And so what I'm gonna do is I'm gonna give myself some room here. So what I'm gonna do is our answer is gonna be, it's gonna be, just go back here. This gives me the template of how to do it. Go back here, A to B. And so we say A is 0, B is 1. And we're gonna take f of x. And so here's our f of x is gonna be that guy right here. So we're gonna take x plus 8 minus g of x, which is x cubed
Oh, I'm a dummy.
plus 8. And so we have dx, right? And so we subtract out here, we're going to get 0 to 1, and we'll get x. The 8 minus 8 will just cancel each other. And you can see that if we translated both of these, right? If we translate both of these down, in fact, that's a trick you can do sometimes. If you can translate down to the origin, sometimes you can make it simpler. So we have is x minus x cubed dx. So now we've reduced this thing to a simple definite integral problem, right? Or at least about as simple as we can have it be. Okay. So did you get an answer for this yet? So we get x squared over 2 minus x to the 4th over 4. And we're going to go between 0 to 1. And it really helps out if one of your limits is 0, because it just makes your arithmetic easier. So you just plug in 1. So we're going to get 1/2 minus 1/4. So we're going to get 1/4. It's going to be our area between the curves. Okay. Yes, question?
No, he just kept staring at me. When I was doing that.
Okay.
I wasn't staring.
He's keeping.
All right.
I go to the bathroom now. I can do my question.
Yeah, if you can find one.
Yeah. Oh, it's kind of scary out there. It's a scary world out there. Outside of calculus.
Sometimes it's scary inside of calculus, isn't it?
Yeah.
Truth be told.
It's always scary inside calculus.
Is it?
Yes, it is for me.
Is it?
But then I always figure out what I'm doing, so it's not too scary.
One way you look at it, here's what always got me about this thing. When I see a class that other people are in, like if I go to like when I was first taking calculus, just bring that to mention, when I'm taking calculus at college, I look around and I see all these people roughly my age that are in that classroom and they're taking calculus class, and I look at those people and I say, well, in this classroom, my level of intelligence has to be at least average to what this classroom is, right? And so my attitude was, if these people are doing it and can do this, well, I should be able to do it too. Or if I can't do it, I should be able to figure out how to do it.
Well, have you ever heard, I can't remember who said it, but if you're the smartest person in the room, you're in the wrong room.
Yeah, that's right. Okay, and Carson just said this, and I'm going to say it back because he said, he asked the question, or he made the statement, if you are the smartest person in the room, you are in the wrong room.
I didn't come up with that, I don't remember who.
No, and that's not a lot. I don't agree with that 100% of the time, because sometimes you're going to be the smartest person in the room for that thing because you are needed in that room, because you are needed to help that room. Like if I say, okay, well, when it comes to calculus, right now, even though we have other smart people in the room, when it comes to this subject right now, I happen to be the smartest person in this room, just because of my experience, right? And so that's why it's important for me to be, but I go into these, but that's why it's really helpful for me sometimes to go into, like the summer before last, I went and took that linear algebra course. And I saw those other people commenting, and those people there were like IT majors and computer science majors and other things. They were young, they looked like they were probably from India, most of them. And I say, well, when it comes to the smarts for this thing here, no, I'm not the smartest person in this room, okay? But if I work hard, I can hold my own, which I did. I ended up getting an A in the class. And so if you just kind of look at it that way, and I happen to have on my, I have my T-shirt today that is the same thing here. See?
What is it?
What is the biggest room in the world? You remember that from last year?
I don't actually.
You remember it?
It wasn't classroom, was it?
A room for improvement.
That's what it was.
The room for improvement. So what you do is you're going to improve. And sometimes what happens, I go into these, when I go to these calculus teacher seminars, I go in there and these people are in this class, they're all calculus teachers and I am.
They just spilled water. There's water on the hallway too, I'm gonna die.
So these are calculus teachers like I am, and I find that in those groups like that, I don't think I'm maybe necessarily the smartest person in the room, but sometimes I'll have really good insight, so I'll be the good student that makes a comment. Then we get together for groups, and then there'll be somebody who has something figured out really faster than I am capable of figuring it out. So when it comes to that, but that's good for me to interact and see what that's like. Yeah. So the idea of that statement, if you're the smartest person in the room, you're in the wrong room, is try to go someplace where you're challenged. It's like if LeBron James is out there playing basketball with a bunch of 10 years old and he's there making layups and dunks and all this, you got these 10-year-old kids.
LeBron James is overrated.
But that's not the argument here. But what you're doing here is he's not in the place he needs to be, right? He needs to be where he can compete and people can challenge him, right? And he does that. So, same principle.
Tom Brady's also overrated.
Tom Brady is overrated.
Well, Tom Brady.
I call it more the people hop. This fan base is overrated. It's called that.
Here we go.
Bandwagon.
Tom Brady.
Ew.
The former Tom Brady.
You can't deny he's not a good player, but
He's a
there's
good
so many
player,
people that
but-
hop on the bandwagon.
He's not the best player in the world.
He's not the best passer.
I never said that.
He's not the GOAT.
Yeah, I never said that.
Okay, well,
He's
we're
also
gonna
had some
have,
good-
Sorry,
he's
Mr.
had-
G. Sorry, Mr. G.
He's also had some great teammates.
We have some very strong
So it's-
opinions
it's-
about Tom Brady.
capable.
Because he's the quarterback. Or the, what?
So he's with
He's with the Buccaneers.
Buccaneers now.
Going to,
all right,
going to the Super Bowl.
I know, I just find it funny.
now we're to note card 49, so that was really fast. It's the same principle. But this is something that's called area with respect to y. And let me show you what that looks like. Now, this is one thing that at first glance, it kind of blows my mind a little bit. So what this is instead of y in terms of, instead of x in terms of y in terms of x, you have x in terms of y. So you can have an x equals equation. So what you're doing in this case is you're drawing, your function is going to look like this. Because in this instance, this does not look like a function, does it?
No.
But what it is, you have to, if you can consider that you're turning this thing 90 degrees, then you would have a function, wouldn't you? So you have y in terms of x. And one thing you could actually do with this, if you want to, you can consider it like this, y and x and write it out in this sort of orientation to see what's going on here, and just change what it looks like, but in every other respect, it becomes the same type of problem. Does that make any sense? So you're going to have an x equals equation. So instead of a y equals equation like you normally would, you've changed with the orientation. So you're going to have something, something, something equals x, but then you'll handle it. But then what you're going to have is you're going to have dy. So you're looking at, what you're looking for is you're looking for these rectangles here. The dx is this. And when you make these infinitesimally small, that is the definition of the integral that gets you the answers, okay? So let's go ahead and look at, and then if they use C and D instead, well here's, okay, C, so here would be C and this would be D, and so you're integrating between C and D of this function here, which is going to be g of y, and you subtract out g of f of y, f of y. And so to me, initially when I started looking at these things kind of confused me a little bit, but if you reorient it like this here, or sometimes you can change the letters to x and y and leave these x and y and just reverse the letters of them. So there are ways to make it more comfortable for you is what I'm saying. So let's go look at a problem. And this is the problem right here, where you have this curve, y squared equals 4 plus x, and the chord AB joining points A and B on the curve. And so what we have here is an xy coordinate plane. So here's x, here's y, and we have instead y squared. Well, how can we solve this equation for y?
Square root that.
Yeah, y is going to be equal to plus or minus square root of 4 plus x, right? Take the square root of both sides, right? And that, if you do this, what is that going to look like? Well, if you had like what you're going to have is a square root curve, right? Where's going to be the zero of this thing?
-4.
Yeah, -4, 2, 3, 4. So we're going to be talking about the plus version is going to look like this, right? And then region R and the curve and the chord AB joining A and B. So here's our A right here at -4, 0, and here's our B at 0, 2. And here's the chord joining the two, or the line, yeah, chord AB and the chord AB, okay? So what area are we talking about? This one right here. So we have our equation for this. What's going to be our equation for this thing right here? Y equals, what is this line going to be here? What is our y-intercept?
1,
2. There's our y-intercept.
1/2.
So we're going to have 1/2 x plus 2. And then to find what that is in terms of y, we're going to have, here, we're going to have x equals y squared minus 4. That's what that is going to be. What is this going to be? We'll have 1/2 x equals 1/2 x equals y minus 2. So x equals 2y
Minus.
minus 4. So that's what you have to work with.
So the minus 4s can cancel out.
Essentially, your minus 4s are going to cancel out. And so that's like the other ones where you can move up like this. And so if you're going to say that's your g of x and your f of x, what's going to be your limits of integration here? You're going from y equals,
-4 to 0.
no, you're going this way,
Oh, that way, haha. It's going to be 0 to 2.
0 to 2. And you're going to take one minus the other. And I'm going to tell you a mistake that happens. So we're going to take this thing right here, which is the line, which is going to be 2y minus 4. And then we're going to subtract out this y squared minus 4. And then we have dy right here. Okay, and so now do you have a problem that's pretty simple like the other one? Yes, no? Yeah, you do really. Let's go ahead and work that out over here in a minute. So, these things here are going to cancel out, minus 4, and this is going to be minus -4, so those will cancel out. So we'll be able to work out this. We're going to have 2y squared divided by 2 minus y to the third power divided by 3. And we're going to go, those will cancel out, we're going to go between 0 and 2. And so we plug in, we're going to get, and again we have a 0 as a limit of integration, that helps us out. So we're going to have 2 squared minus 2 cubed over 3. So that's going to be 4 minus 8/3, which is the same as 12/3. Is that right? Minus 8/3, which is going to be 4/3. Now, I'm going to share a piece of my
Calculus time.
okay. I'm going to share some of my experience with you. Is often it happens to me that I go work these out and I get a negative answer. What could cause a negative answer?
A lot of subtraction.
Yeah, so just kind of a basic arithmetic error, that could cause it. What could cause an error that's not an arithmetic error, but still gives you a negative?
You switch them.
Yeah, what happens is, it's really easy to get these things mixed up, because let's say we had this thing minus this, then we would have got -4/3. So I've had a question about how you get around that. How do you get around your mistake? If you come around in 4/3 and you get a -4/3 and you're required to show your work and your work needs to be correct, how do you make it correct without having to go back and redo everything? let's say we switched it, came out with -4/3, how can I go back and fix everything so now it's correct?
You just make one negative.
Yeah, you can go ahead and do that, you can make that negative. Are you talking like this, Aaron?
Yeah.
So if you make this negative and this positive, but another thing you can do too, is you can just go like this.
Absolutely.
You can make it absolute value. So there's some retroactive things you can do if you, because if you work out something like this, and you think about erasing it and redoing it and all that to get it exactly right, that's gonna be almost a project doing it. I mean, it'll take some time doing it. But if you go ahead and do that, but I think Aaron made a good suggestion too about changing the minus and the plus, that could work out too. But when you do this, you're saying, well, I'm not sure which is which, but whatever it is, I know that my absolute value brackets are gonna take care of that situation if it occurs. All right, let's go to next one. Okay, we get into some exercises here where they talk about find the region by this, and they give you a couple examples. One, where you give between x equals 0 and x equals 1. So you can go find, say, first sketch it, and then draw it. So here you have between 0 and 1. So you're talking about these areas here. So I want you to go ahead and start working on that today. And then we're going to pick up back on this on
Monday.
Monday. Maybe without the hiccups.
Yeah. No, probably not. I won't be here next week on Friday.
You'll be here Monday, right?
Yeah, I'll be here Monday and Tuesday and Wednesday. I don't know about Thursday.
Monday and
Friday.
Tuesday, but not.
You wanna,
Yes.
here.
Okay, yeah. Okay, homework.